All right. So I'm gonna go ahead and start. If you have any questions, just as you have them, um, post them in the chat. Again, you can email me. Email me is probably not great right at this moment because I don't have a tab open for that. But I will check kind of periodically. Couple of things I want to do. So I want to go over different types of questions on the test, which you all have the practice test, so you should know already. But just in general, how to do them. So we're going to go over general cases first. So different types of multiple choice. Then we'll get to graphing, and then we'll get to identities. After we go over like one of each, how to do each one very basically, I'll go over the entire practice test. And after we go over the practice test, if there's still a little bit of confusion or other questions, I can pull questions from like the other banks of questions that are in on campus. All right. Again, ask questions as I go. I'm going to try and explain everything as well as I can. And if you have to leave for whatever reason, this will be up as soon as this ends. All right. So give me like 2 seconds to set a couple other things up, and then we'll get started. All right. So first type of question, and probably the most basic question that you'll see, have to do with coterminal angles. And if you recall from class and or other videos, coterminal angles are basically the same angle. They're just one rotation of a circle different. So either greater than or less than the original angle. So in order to find coterminal angles, if we're in degrees, you just add 360 degrees. Add or subtract. And then whatever your answer is, that's the coterminal angle. So for example, say we have an angle of 37 degrees, and say we want a positive or negative coterminal angle, positive and negative. 37 plus 360, that's 397, and 37 minus 360 is negative 323. Okay, so again, in order to find coterminal angles in degrees, you just add or subtract 360 until you have your desired answer. All right, in radians, it's a little bit different. Same idea though. You are adding or subtracting 2 pi. Okay, so this usually requires a little bit more effort because in a lot of cases you're just going to have to add fractions, which a lot of people will struggle with a little bit. So say, for example, we have pi over 4, and we want a negative and a positive coterminal angle. To find the positive one, we have to add 360, or sorry, 2 pi. And in order to add these two things together, we need to get a common denominator. So in order to get a common denominator, you have to multiply 2 pi by 4 over 4. So then we have pi over 4 plus 8 pi over 4. And then as soon as we have that common denominator, we just add across in the numerator. So we get 9 pi over 4. In order to get the negative coterminal angle, we have to subtract 2 pi. So we have pi over 4 minus 2 pi. And again, you kind of have to do the same thing where you get a common denominator. Once you have that common denominator, you can just deal with the numerator. So pi minus 8 pi is negative 7 pi. And we have our two answers. So that's coterminal angles. That should be one of the easier things you do. The next thing we need to do is, I guess, converting degrees to radians. All right, and when we're converting from or to degrees or radians, we have to keep in mind our conversion factor. All right, so in degrees, every 180 degrees, there's exactly 1 pi radians. So 180 degrees is the same as pi radians. Pi radians is the same as 180 degrees. So we're going to use this conversion as pi over 180 or 180 over pi. So you're multiplying whatever your initial question is by this, pi over 180 or 180 over pi, depending on what you're converting to and from. So for example, if we want to convert 60 degrees to radians, we have to multiply by our conversion unit of pi over 180. And a really easy trick to know what you're doing or know what you're multiplying by. If you have degrees, your other degree factor needs to be in the denominator. Okay, so when we do this, we get 60 pi over 180. And then if we simplify that, we just get pi over 3. If we have radians, so something that looks like pi over 4, and we want to convert that to degrees, instead of pi over 180, we're multiplying by 180 over pi. And when we do that, we get 180 pi over 4 pi. These pi's cancel. So we get 180 over 4, which is equal to 45. Okay. The next kind of two different types of questions just have to do with you knowing two different equations. The first is arc length, which is S. And in order to find arc length, you multiply the radius by the angle, but your angle has to be in radians. And given any two of these variables, you should be able to find the third. So very, very basically, and we'll do this later when we do the practice test. Say we're trying to find S given a radius of 4 feet and an intercepted angle of pi over 4. S then would equal 4 times pi over 4. Those 4's would cancel, so S would just equal pi. The other type of question that we need to know, again, it's just an equation. A area is equal to 1/2 the radius squared times our intercepted angle, which again has to be in radians. So really, these two questions are just plug and chug. If you know the equation, it should be very simple. So say we're trying to find the area given a radius, again, of 4 feet and an angle of pi over 4 radians. Area then would equal 1/2 4 squared times pi over 4. And I think a lot of people can set this equation up right. The next thing that people struggle on is actually carrying this out. It's very basically just order of operations. So the first thing you do is square the 4. So this is 1/2 times 16 times pi over 4. So again, arc length, area of a sector of a circle, just know those two equations and you should be fine. The next thing has to do with right triangles and circles, and Sohcahtoa. All right. So I guess one of the more basic things is just completing a triangle. So say we have the given triangle, the given right triangle, marked as is, and we're trying to find just the ratio of cosine. Well, let's say sine. So say we're trying to find the sine of theta. Sine is always going to be opposite over hypotenuse. So the opposite of angle theta is 4. The hypotenuse is 16. So it's just 1/4. The next is, so what we just did is right triangle trig, at least very basically. The next thing you'll have to know is the circle part of it. So say you're given an angle on a plane. So in this case, 300 degrees, and we're trying to find tangent. You need to know that tangent on a circle is always going to be the y coordinate over the x coordinate. And in this case, given this angle, you would go to your unit circle, which I will try and copy in here in a second. But you go to 300 degrees, you get the y coordinate, which in this case is -√3/2. And then you get your x coordinate, which in this case is 1/2. Now this won't be an option. Instead, you'll have to rationalize it. Okay, so when we are dividing, we're really multiplying by the reciprocal. So we can rewrite this as -√3/2, and then multiply by the reciprocal of 1/2, which is just 2/1. When we do that, we get -2√3/2, which just simplifies to -√3. All right, so we have to know sine, cosine, and tangent for all those, as well as cosecant, secant, and cotangent. Okay, so we need to know the identities that sine is always the y coordinate, cosine is always the x, tangent is always going to be y/x, cosecant is 1/y, secant is 1/x, and then cotangent is just the reciprocal of tangent, which is x/y. All right. Now, I said before, you will receive one identity for the identity part of the problems. You will not, though, receive these. Those you have to know. Those I'm expecting you to know. All right. The next type of problem is really just calculator work. So say we're given this figure of a triangle, we're given a degree measure, we're given a hypotenuse, and we're given a side that we're trying to find. Okay. The first thing to do is identify which sides are given. In this case, we're given the opposite side and the hypotenuse. So we need to use the trig function that has both of those, which is sine. So sine of our angle, 47, will equal the opposite side, so x, over a hypotenuse, so 15, and we have to solve for x. So in order to get x by itself, we have to multiply both sides by 15. So we get 15 times sine of 47 degrees. You plug in this into your calculator, and you get an answer. So when you plug this in, so long as your calculator is in degree mode, you get 10.97. Okay, and again, you could be given the adjacent side, you could be given the opposite, or you could be given the hypotenuse. You will always be given one of those two. Okay, those are all the more basic questions, or at least brief overviews on how to do them. Then we have to get to graphing and identities. Before we do that, are there any questions on anything so far? All right, so if there are no other questions, I'm going to move on to graphing sine and cosine. Then we'll do tangent. And actually, I'm probably going to do secant and cosecant along with sine and cosine. But we'll start with sine first. So on the test, I think like number 10 or 11 is to graph something that looks like this, which you will either be given a sine or cosine graph. And then the next one is to graph its reciprocal function. So in this case, first you're graphing sine, and then the next question would be to graph the reciprocal of this, which you should know is cosecant. All right. Regardless, no matter what I ask, even if this was a secant or a cosecant, you go back to the original function. So in this case, sine. All right. And there's work that I'm going to be expecting you to do first. So the first thing you need to do on a sine, cosine, secant, or cosecant graph is to identify the amplitude and the vertical shift, which you're not doing any math to do. All right, so the amplitude is always the thing attached to the sine, so the thing you're multiplying by sine, which in this case is 4. And I'm going to change this over here so people don't get confused. And then the vertical shift is the thing that it is being subtracted from the sine or cosine. So in this case, -3. Then we need to find a start point. Which I'm not going to explain why all of this does. That's what class is for. But we set everything inside parentheses equal to 0 and solve for theta. For the endpoint, you do the same thing, but set it equal to 2 pi. And again, solve for theta. If I were you, I would not simplify either of these. That makes it easier to do the different points on the graph and the period, which we have to get next. All right, so next, period. I think the easiest way to do this is to take the difference between the endpoint and start point. So we do -3 pi over 3 minus pi over 3. So we're just trying to find the distance, right? So -3 minus 1, that's -4. So our period in this case is -4 pi over 3, but because we're talking about distance, this has to be positive. Sorry, that should be positive. That changes a couple things. My bad. All right, so 3 theta is equal to just pi. So theta is equal to pi over 3. All right, and then the distance between those two things is pi over 3 minus a negative pi over 3, which is just 2 pi over 3. All right, so this is all the work I'm expecting up front. Then we can start to graph. So our center line is always our vertical shift. Our maximum is always our vertical shift plus our amplitude, so -3 plus 4. Our minimum is always our vertical shift minus our amplitude, so -7. And then we have to know the shape of the sine or cosine graph. So sine always starts in the middle, whereas cosine starts up top. And then we need all the points circled. So we already found the start point and end point. This is negative pi over 3, comma -3. This is positive pi over 3, comma -3. Then each of these points is equidistant apart. So what I do first is to find the center of that distance. So the center of negative pi over 3 and pi over 3, if we look at that like on a number line, -1, 0, and 1. So our center point is 0. So this is 0, -3. And then on either side of that, this point right here is equidistant from our center and our end. So we need half of that distance. That's great. I'm going to go over the practice test after I go over this stuff, as I said before, so just wait. So we need half the distance of pi/3. So we multiply by 1/2 to get pi/6. So this point right here is 0 plus pi/6, comma -7. All right. Are there any questions about graphing sine? So again, this is all the work I would expect for sine. And cosine, it just starts at a different place. Okay. After you actually graph the sine, the next problem would be to graph everything the same but cosecant instead. In order to do that, you would literally copy everything of this, and that's most of the problem. All right. Then you would identify your asymptotes, which is every point that crosses our center line. So those dotted blue lines are asymptotes, and I would want you to identify their actual equation. So in this case, this is theta is -pi/3. The center one is theta is equal to pi/6. And this right one is theta is equal to pi/3. After you identify all those asymptotes, then from your maximums, you draw up toward the asymptote but never cross it. And you do the same on your minimum, but you're drawing down. And that is literally it. That is cosecant. It's the same for secant, for cosine. You would graph cosine first, then you would graph secant. This is what I would be expecting. Then there's tangent. And tangent works just a little bit different. Again, the first thing you would do is identify stuff that doesn't require any math. And the only thing that matters here, for our sake, is the vertical shift, which in this case is just -1. So it's always a thing being subtracted or added to the tangent function. Then we need to get two asymptotes. In order to do that, you set everything inside parentheses equal to pi/2 and 3 pi/2. There's reasons for that. We went over it in class. I'm not going to go over it right this second. But then you just solve for theta on both sides. So 2 theta would equal pi/2 minus pi. And then 3 pi/2 minus pi. And again, we have to get common denominators. And then we have our three kind of important things, and then we can start to draw the graph. So the first thing, plot your asymptotes. So this blue line will be -pi/4. This right blue line will be pi/4. Our center line is -1, and then we can start to draw the graph. And I'm expecting you to be able to get this point, and this point. And in order to do that, you find halfway between your two asymptotes. So this center point will be directly between -pi/4 and pi/4, which in this case is just 0. So this point is 0, -1. And half the distance between pi/4 and +pi/4 is just pi/4. So we subtract pi/4 from -pi/4 to get this point, which would be -2 pi/4. And add it over here. So pi/4 plus pi/4, that's 2 pi/4. And this is -1. Okay, so that's tangent. It should be easier than graphing sine, cosine, secant, or cosecant. It's objectively less math, right? And then the next thing, which I'm going to save for the actual practice test, is identities. Okay, so at this point, we'll go over each of the problems. One by one. Okay. Starting with number 1, we want a positive and a negative coterminal angle, so we need 2. So we need to add or subtract 360. Such that we get a positive and a negative coterminal angle. So 185 plus 360 is 545. And then 185 minus 360 is negative 175. So then our answer is B. Number 2, we have to add 2 pi and subtract 2 pi. So we get 13 pi over 4, negative 3 pi over 4, which is option D. Converting, so we have radians and we're converting to degrees, so 53 pi over 12 times 180 over pi. The pi's cancel. 53 times 180 is 9,540. We're dividing that by 12, which is 795. Number 4, find the radian measure of the central angle of a circle of radius 9 feet, intercepting an arc length of 15 pi over 2. Okay, so again, our equation S is equal to r theta. We're given 2 of those variables. We are given radius, which is 9 feet, and an arc length, S, of 15 pi over 2. So then we just plug those in and go for it. So 15 pi over 2 will equal 9 theta. So in order to get theta by itself, we need to divide by 9. So we get 15 pi over 18 is equal to theta. Which is B. Number 5, again, our equation is 1/2 r squared theta. Find the area of the sector of a circle with radius 5 feet and central angle 90 degrees. So radius is 5 feet, theta is 90, but we have to convert this to radians, and 90 degrees in radians is pi over 4. Sorry, pi over 2. So area will equal 1/2 times 5 squared times pi over 2, which is equal to 25 pi over 4, which is option A. I'm not sure what else you want me to explain. I mean, there's different ways to do it, and they're really all the same, but all you're doing is solving for theta. So 15 pi over 2 is equal to 9 theta. We have to get theta by itself, so we can either multiply by 1/9 or divide by 9. Yeah, so if we divide by 9, we had 15 pi over 2 divided by 9 is equal to theta. When we divide by a fraction, we're multiplying by its reciprocal. So 15 pi over 2 times 1/9 is equal to theta. So 15 pi over 8. Number 5 is the same way. You're literally just plugging in variables and then solving for a. You probably got D because you did not convert 90 degrees to radians. So if you just use 90 degrees, which you cannot do, you get 25 times 90 divided by 2, which is 1125. You cannot do that. It has to be in radians. Give me 1 second. I'm going to get a unit circle up so you can see what I'm talking about. Okay, number 6, find the exact value of each trigonometric function. So this is asking sine of theta given an angle of 405. When you are given something that looks like this, the first thing you need to do is to find out what angle you're actually dealing with. So in other words, we have to find this angle right here. In order to do that, you just subtract 360 or add 360 until you get a number between 0 and 360. All right, so 405 minus 360 is 45 degrees. So the angle we're actually dealing with is 45. Once you get that angle, you go to unit circle, 545 degrees, and we want the sine value, which gives us y. So the y value at 45 degrees is root 2 over 2, comma root 2 over 2. So the y value is just root 2 over 2. So the answer is D. Tangent is a little bit trickier because you're taking a ratio of two things. So we are dealing with the angle of negative 480. So we have to add 360 until we get a number that we can deal with. And once we get that number between 0 and 360, we go to that number on our unit circle. So we're dealing with 240, which has a y value of negative root 3 over 2, and an x value of negative 1/2. So tangent is always the y value over the x value. But this isn't one of our answers, so we need to simplify and rationalize. So when we're dividing by a fraction, we're really multiplying by its reciprocal. So this is really negative root 3 over 2 times negative 2 over 1, which is 2 root 3 over 2, which just simplifies to root 3, which is A. Number 8. This is just a calculator problem, really. We are given an angle 46 degrees, and we are given the hypotenuse. So we need to use those two things in order to solve for x. X, in this case, is the adjacent side. So we need something with the adjacent and hypotenuse, which is cosine. So if we set up our equation, we have cosine of our angle 46 is equal to x over 6. When we solve for x, we multiply both sides by 6. And then we plug this into a calculator and get an answer. So when we do that, 6 times cosine of 46 degrees is 4.167. If we round that to the nearest tenth, we get 4.2, which is A. On number 9, we're dealing with inverse trig, which is like the one type of problem I didn't go over. But it's kind of the same thing as number 8. We have an angle theta, we have a hypotenuse, and we have an opposite side. So the first thing we need to do is to set up our trig ratio. So sine of theta is 6 over 15. And in order to undo sine, we need to take the inverse sine of both sides. So you don't have to show this. I'm just showing you this so you know exactly what's happening. So the left hand simplifies to just theta, and the right hand side is sine inverse of 6 over 15, which if you plug that into a calculator, it's second and then sine, and then the fraction 6 divided by 15, which comes out to 23.6 when you round to the nearest tenth, which is option D. Number 10, it's really just an easier version of number 8 and 9, except you need to know what cotangent is. So in this figure, we're given theta, we're given the opposite side, and we're given the adjacent side. So cotangent of our angle is going to be our adjacent over our opposite, which again is something I'm expecting you to know. So then that is 15 divided by 20, which is 3/5. And before we go on, I'm going to leave this up to you because we already did graph a sine function and a cosecant function and a tangent function. Do you want to do this specifically on the practice test, or should we go over to identities? Yeah, you're right. It doesn't simplify to 3/5. It simplifies to 3/4. So identities or graphing again. Okay. We will do number 11. I'm going to change it just a little bit. So we'll do number 11 and 12 on this one page, just to save time and space. I'm going to change this problem to cosine. And then we can graph secant. So it's a little bit different than the example we did before. All right. So again, the first thing you need to do is to identify amplitude and vertical shift. Amplitude in this case is 3. Vertical shift is 1. Then we need a start point by setting everything inside parentheses equal to 0. And then solving for theta. Do the same thing for the endpoint, but set it equal to 2 pi. And then we find the period. And then once we have all that info, we can start to graph it. Our center line is going to be 1. Our maximum is going to be 4. Our minimum is going to be -2. So our vertical shift plus our amplitude is 4. Our vertical shift minus our amplitude is -2. Because it's a cosine graph, it starts up top. And then it comes back up. And we need to find this point and the end point, the minimum, and where it crosses our center line. So we already have our start point. I'm going to do this over here. -5π/12, 4. Our endpoint is π/12, 4. And then we need half the distance between that. So you see that our period is 6π/12. Half of that distance is 3π/12. So this point, halfway between them, is -5π/12 plus half the distance, which is -2π/12. So our point is -2π/12 comma -2. And then we have to do the same thing, but for these points. So half the distance between -2π/12 and π/12 is 3π/12. And then half of that distance, so the distance between our minimum and this point is half the distance. So the distance between those two is 3π/12. Half of that is 3π/24. And we have to add that to this point. So Noah, it's always equal to 0 for sine and cosine. For tangent, you're setting it equal to π/2 and 3π/2. Okay, I did a little bit of work without explaining it. Most of it's just adding fractions. That's all we're doing. So that's the cosine graph. Then we have to find the same graph, but we need the reciprocal function. Which would be this. But we don't really need to show any work because we have all the work that we need. We have the minimums and maximums, and we have our x-intercept, or our vertical shifts, right? So everywhere it crosses the center line, that's an asymptote. From our minimums, we draw it down toward our asymptotes, and from our maximums we draw up toward our asymptotes. And that is cosine and secant. So I'm going to try and quickly go over tangent. So we just did 11 and 12 on that problem. So red is 11, and then the darker blue, that's 12. For number 12, you can do both of them on one sheet. I actually would just copy the graph onto the next sheet and then make it a little bit cleaner, but it's up to you. For number 13, we're dealing with tangent. So we have to find two asymptotes. And those asymptotes happen at pi over 2 and 3 pi over 2. But first, we can find our vertical shift, which in this case is -2. Then we find our asymptotes by setting everything inside parentheses equal to pi over 2 and 3 pi over 2. So we get pi and 3 pi. And that's all we need to start graphing. So our vertical line is -2. Our asymptote is pi and 3 pi. And then draw the parent function. And then we need to find 3 points, which is really just halfway between each of these asymptotes. So halfway between 1 and 3 is 2. So this point right here is 2 pi -2, which means this point must be 0, -2, and this point must be 4 pi -2. And that's tangent. So tangent should be easier because you're just really finding one distance. So before I go to identities, which will probably be the last thing, are there any questions over any of the graphing? Okay, the last thing that we need to go over, at least just a little bit, are the identities. So there are three different types of identities. There's the reciprocal identities. These things we should absolutely 100% know. And we probably knew it before we even went over this in class. Um, Sine is the reciprocal of cosecant. Cosecant is the reciprocal of sine. That's all that first line is saying. Cosine is the reciprocal of secant. Secant is the reciprocal of cosine, and then tangent with cotangent. Um, all of this you should absolutely know. Same with the quotient identities. Tangent is y over x, which is the same as sine over cosine. Cotangent is cosine over sine, or x over y. The only thing that you probably don't know right off the top of your head, which is okay, are the Pythagorean identities. And for the test, I will probably give you the Pythagorean identity that you need. I will not modify it in the way that you will probably want it. I will probably just give you one of these three, and you will have to use them in any way that you can, right? So I want to go over a couple of examples. There will be two on your test. You will not be given anything in white or green. You will be given one of the things in blue per problem, depending on the problem. So, for example, and this is from the review that's in on campus. The first thing you need to do is to figure out if you can simplify anything immediately. So if there's like an obvious Pythagorean identity, tan squared plus 1, a cotangent squared plus 1, a sine squared plus cosine squared, if there's anything like that, just simplify it immediately. The more you can reduce it right off the bat, the better. Other than that, if there's anything that looks like a Pythagorean identity, then you need to do that. So the first thing that I notice is this in the denominator, which looks a lot like sine squared plus cosine squared, but it's both of their reciprocals. So the first thing that I'm going to do is to change this to tan squared of x times 1 over cosecant squared of x plus secant squared of x. And then once we get there, so we have tan squared of x times 1 over cosecant squared plus secant squared. We can take the reciprocal of this. So this is 1 over cosecant squared of x plus secant squared of x, which is really equal to just sine squared of x plus cosine squared of x. From our Pythagorean identities, we know that this is equal to 1. So that entire thing is just equal to tangent squared. And then from our quotient identities, tangent is sine of x over cosine of x. And because that tangent's squared, both of these things are squared. And then we proved it. Another example. So this is number 14 in that worksheet and on campus. Cosecant squared of x times tangent squared of x is equal to tangent squared of x plus 1. Again, the first thing to do is to use any Pythagorean identity that you can and simplify it as much as you can. So I noticed that this right-hand side is this identity right here. So we can just replace that with secant squared. But then we don't really know what's happening. So I'm going to move to the left-hand side and rewrite both of these into what they're both equal in terms of reciprocal or quotient identities. So cosecant squared is 1 over sine squared. Tangent squared is sine squared over cosine squared. When we multiply these two things together, these signs cancel, which is 1 over cosine squared, which is secant squared. And because these two things are equal, we proved it. Okay. Yes, we can go over 1 or 2. Otto, what are you exactly talking about? Can we go over how you got the Pythag identity from the original equation? I'm not sure what you're talking about. Okay, on this. Okay. So that denominator is cosecant squared plus secant squared. Right? We know that cosecant squared is the reciprocal of sine squared. We know that secant squared is the reciprocal of cosine squared. And we know that sine squared plus cosine squared is equal to 1. All right, so I'm going to redo this maybe so it's a little bit more obvious. So I'm going to copy it. So really, if we wanted to, instead of doing it like I did, so we can rewrite this entire thing like this. And I know this seems like really tedious, but we can do that, right? Which means that we can take sine over cosine and multiply it by the reciprocal of this denominator. And actually I'm going to do a little bit more work so you can see. If we add these two things together in the denominator, in order to do that, we have to get a common denominator. So we'd have to multiply this left one by cosine squared over cosine squared, and this right one by sine squared over sine squared, which gives us cosine squared which means that we can do cosine squared plus sine squared over cosine squared sine squared, which is really just equal to 1 over cosine squared times sine squared. All right, so this and this are both the same thing. So then, and I know this is long and winded, but I want to make sure you understand this. So then we can rewrite sine squared over cosine squared divided by this. And if we do that, we're really multiplying by the reciprocal of this. So we have sine squared of x over cosine squared of x times the reciprocal, which is just cosine squared times sine squared over 1. And then we can start to cancel stuff. So because there's a cosine and we're multiplying, wait, that's not right. going to go with it and see where it goes. All right, so then these cosines cancel. So we get sine to the fourth. Honestly, I think the other way I did it was just better. um, yeah, okay. This is way messier, and it's probably confusing you more. So just do this. Stop, unclick it. This denominator looks a whole lot like the reciprocal of this. So we just replace those, and it's just 1. And then we're just left with tangent squared. And tangent squared is equal to sine squared over cosine squared. All this in red is way more confusing than what I want it to be. All I want is for you to see that this in blue looks like this. Okay, so hold on to that, and I want to get to a couple more just so you can see it. I'd rather not fill around with something that I haven't done yet than actually get you guys to understand what's actually happening. All right, so I want to do number 1 and 2 from that worksheet. Which says 1 over cosecant squared of x minus 1. And we want to prove that that's equal to secant squared of x minus 1. Okay, I don't know what's happening. There we go. All right. One of our identities is cotangent squared plus 1 is equal to cosecant squared. If we rearrange this and subtract 1 from both sides, we get that cotangent squared of x is equal to cosecant squared of x minus 1. All right, so this appears right here. So we can rewrite that as 1 over cotangent squared of x. 1 over cotangent squared of x, and there should be a minus 1 on here. So 1 over cotangent squared of x is equal to tangent squared of x. And we know that tangent squared of x from our other Pythagorean theorem, Pythagorean identity, is equal to secant squared of x and if we rearrange this by subtracting 1 on both sides, we get secant squared of x minus 1. So then we can replace tangent squared of x with secant squared of x minus 1. Hold on. Short answer to can you do the one from the practice test for the identities? No, because I accidentally deleted that. It was a separate worksheet. I just generated it and printed it. I didn't save it. So no, we cannot. Unless you want to give it to me in some way, shape, or form. All right. This one actually is decently easy. I'm going to separate this left-hand side into 1 over secant of x times 1 over cosine squared of x. You should know from the identities that 1 over secant is just cosine, and 1 over cosine is secant. And because it's squared, that squared follows it. So you just get cosine of x times secant squared of x. Because these two are equal, we did it. Number 2, I actually think for both of these, you don't even need any of the Pythagorean identities. I'm going to rewrite the left-hand side as tan squared of x times 1 over sine of x. Tangent we can rewrite as sine squared over cosine squared. When we multiply these two things together, these signs cancel, which is just 1 over cosine squared of x, which is what we're trying to prove. So those are the last two problems on the test. I think pretty much everything I've done, except for all this stuff in red, it's pretty reasonable. Okay. So that's everything on the test, and we've gone over most things 2 or 3 times. I'm going to leave this open for the next 5 or 10 minutes. If you have any other questions, I'm happy to go over it. But we've been going since 7:20. So again, I'll leave this open. Type in chat. I'll keep an eye on it. I'm going to close this down. If you have any questions, I'll be there tomorrow morning, or you can just email me as well. Thank you.